I'm presenting our work on skill transfer for temporal task specification. We address the problem of learning policies from a set of training tasks, then transferring to a wide variety of novel tasks in zero shot in the same environment without access to the transition dynamics. Previous learning-based methods require a large amount of training data to generalize and do not provide safety guarantees. Our proposed method, LTL-Transfer, has three parts. 1. Learning policies for state-centric options from a set of training tasks, specified by linear temporal logic. 2. Decomposing state-centric options to transition-centric options. 3. Applying transition-centric options to solve novel tasks in zero shot. Given an LTL task specification, find out X and find out iron, which means collect X and iron in arbitrary order in a Minecraft-inspired grid world domain. We first translate the LTL task specification to a reward machine shown here as a graph. The nodes represent reward machine states that encode the progression of the task. The edges are labeled by Boolean formulas. If satisfied, progress the task to the next state of the reward machine. We decompose the given LTL task to subtasks encoded in the reward machine state 0, 1, and 2. Then we can use any RL algorithm that solves LTL tasks to learn a policy for each subtask. The policy for state 0 transitions the reward machine from the initial state 0 to state 1 or 2 depending on the proximity of the robot to the X and iron in the environment. Similarly, we can learn a policy for the subtasks encoded in the state 1 and 2 of the reward machine. After learning state-centric options, we decompose them to transition-centric options by partitioning the state space. As an example, the state-centric options for the reward machine state 0 is decomposed to two transition-centric options that target the reward machine transition 0, 1 and 0, 2. While executing a transition-centric option, its self-transition from the current reward machine state is maintained until the targeted reward machine transition is triggered by satisfying the labeled Boolean formula. We can now use the transition-centric options to solve a wide variety of novel tasks in zero shot. To solve the test task, find out the X and find out the wood, which means first get X then wood. We first apply the transition-centric option learned from the first training task to progress the reward machine from the initial state 0 to state 1 through the edge transition not wood and X. Then we apply the transition-centric option learned from the second training task to progress the reward machine from state 1 to accepting state 2 where the edge transition would. During execution, LTL transfer aborts whenever the learned options are not sufficient to solve the test task to preserve safety guarantees. Results in simulation show that compared to previous methods, LTL transfer achieves higher success rate across different test tasks and never violates the safety constraint. We deployed the LTL transfer at the task planning level of quadruped mobile manipulator. We learned the policy from 20 training tasks, then transferred to 100 novel tasks in zero shot with 100% success rate. We demonstrated 50 of the test tasks on the physical robot.